All right, so we have here in 2000, the population of a country was approximately 6.37 million, and by 2060, it is projected to grow to 11 million. Use the exponential growth model. A is equal to a sub 0 times e raised to the k times t, in which t is the number of years after 2000, to find an exponential growth function that models the data. Okay, so you have your table there. The x-axis represents the year, and then the y-axis represents the population growth in millions. And then for B, it says, by which year will the population be 10 million? All right, so it is telling us that we are going to use our growth model. A is equal to a sub 0 times e raised to the k times t. We're going to use that growth model. So let's identify some information that is given here. It is noted that the value of a sub 0 is, that will be our initial year, okay? Because remember that a sub 0 is the value at the start, okay? So year 2000 is 6.37 million. Then the projected for A is given here. The projected population, A, is 11 million. Okay. So we have A sub 0, and then what is also given here is T. So for part A, it's asking us to, it says here to find an exponential growth function, meaning we want to create an exponential growth equation. This is it. We're going to create this equation. What will it look like? So we need to find T, because it didn't tell us what K was. It didn't say how it was, what decimal it grew by, but we can see by the model it is growing, but we don't know exactly what it is. But we do know that T represents the number of years. Okay, so the value of T is the number of years after 2000. So that the projected population will be reached. Okay, so that will be, you see where it says 2060, we subtract 2000 from 2060. So our T is 60. Okay, so now we're going to plug in everything that we need, because we need to find, we're going to create this equation. So we have to find K. So we have here, let's go back and write this equation again. A is equal to a sub 0 times e to the k times t. So let's plug in the numbers that we have here, the values that we have for a sub 0, and t. We have 11 is equal to 6.37 times e to the k times 60. Okay, so I'm going to put 60k because we want our number first, our coefficient to be first. So we are going to, we want to solve for k, like I said, but before we do that, let's get our base e by itself on one side. So we're going to divide 6.37 to both sides, and we have here 11. 11 over 6.37 is equal to e to the 60 times k. Now, because we're working with base e, to bring down the k, we need to take the natural log to both sides. So ln of 11 over 6.37 equals to ln of e to the 60 times k. And recall, now two ways you can look at this to get to have k by itself. You can use your power rule where we could take this 60k and bring it in front of the ln, and then we have ln of e, which gives us 1 then times the 60k, or we can use our, recall this particular property, ln of e to the x is going to be x. Okay, so now we have here ln of 11 over 6.37 is equal to 60k. To solve for k, we're going to divide both sides of the equation by 60. And then we're going to have to put this information into the calculator. So let's do that. Okay. We have here ln of 11 divided by 6.37. We're going to close it with the parenthesis. And I'm going to go ahead and press enter. And then divide by 60. Press enter. And we're going to round to 2 decimal places. Okay. So we have k is equal to 0.0091049,301. Round to 2 decimal places. So then that will give us k is equal to, we're looking at the second zero, 9 is greater than 5, so we're going to add 1 to the 0, and we have k is equal to 0.01. Now, how do we create our equation? Okay, so now we have our initial population and we have our growth function, which is 0.01. So here's our equation. A is equal to 6.37 times e to the 0.01 times t. This is our equation. This is the answer to part A of this question. Okay. Now keep this equation in mind because we're going to need it to answer B. So I'm going to rewrite this equation again. We have A is equal to 6.37 times e to the 0.01 times t. And then if we go back, let's answer B. It says, by which year will the population be 10 million? So they're giving us A, the projected population. Okay, 10 million. So we are going to substitute 10 in for A. So we have 10 is equal to 6.37 times e to the 0.01 t. And to solving for t, okay, we want to get our base e by itself on one side. So we're going to divide 6.37 to both sides. And we have 10 over 6.37 is equal to e to the 0.01 t. Then take the natural log because we have base E. Take the natural log to both sides. So we have ln of 10 over 6.37 is equal to ln of e to the 0.01 t. So recall on the right hand side, ln of e to the x is equal to x. Therefore, that right hand side is going to give us 0.01 t. We have our left hand side, ln of 10 over 6.37. To solve for t, we're going to divide by 0.01 to both sides. And remember, t represents the time. Okay, so let's go ahead and use our calculator to find out this information. So I'm going to clear the calculator here, and let's go ahead. ln of 10 divided by 6.37. Let's close it and enter. Then we're going to divide this by 0.01. And we have here 45.09856.234, and we're going to round to the nearest year. So therefore, we look at the 5. Our 5 is what we're going to either add 1 to or keep 5 there. But look to the right, we have a 0 that's less than 5, so 5 remains. So we have our time is 45 years. But the question is asking us by which year will the population be 10 million? So we know that um, the population of the country, as we look at this model, it was in 2000. So we're going to add 45 to 2000, and the population in 2045 will be 10 million. So in 2045, the population will be 10 million. There we go.